We're going to take a look at the first example in Chapter 2. A random sample of 20 Starbucks customers was asked which size drink they most frequently order. The results are listed in the table. Construct a frequency and relative frequency distribution. So the frequency refers to the counts. So what we're going to do is we're going to count up all the different people that ordered tall. So we have 1, 2, 3, 4, 5, 6. So the frequency for tall is 6. Grande, we have 1, 2, 3, 4, 5, 6, 7. So 7 of them ordered grande. For venti, there were 1, 2, 3, 4, 5 venti orders. And then for Trenta, we have 1, 2 Trenta orders. So the frequency just refers to the counts for each category. The relative frequency refers to a proportion or a percent, which means we need to divide them by the total. The total was 20. So we'll do 6 divided by 20. So 0.3 will be the relative frequency for tall. 7 divided by 20. So 0.35 is the relative frequency for grande. 5 divided by 20. 0.25 is the relative frequency for venti. And then lastly, 2 divided by 20. And 0.1 is the relative frequency for Trenta. So now we're going to construct a frequency bar graph that displays the Starbucks drink size data. Be sure to include labels. So a bar graph is only used to display categorical data. The bars should be of equal width and they should definitely not touch because that would imply a spatial relationship. So I'm going to start by drawing an axis, which I will label. So I'll make a bar for tall right here, and a bar for grande, then a bar for venti, and I'm making sure that my bars will all be the same width, and then a bar for Trenta. A bar graph can be used to display either frequency or relative frequency, so just make sure you're looking at the instructions. Here it says frequency, so I'll label the vertical axis with frequency. And let's look at the table to see how high the frequencies went. The highest frequency was 7, so I'll make sure my scale goes up to 7. So go 1, 2, 3, 4, 5, 6, 7. Let's label them. Okay, so tall was 6 orders. So 6, 7, 5, 2. Let's see if you can remember that. So 6. So the height corresponds to the frequency. And it was 7. Venti was 5. And then Trenta was 2. Okay, I think I'm going to include a label on the horizontal axis as well. I'm going to put Starbucks drink sizes. The next example is asking us to construct a pie chart that displays the relative frequency of the Starbucks drink size data. Make sure you include labels. So this can be a little bit tricky by hand. It's extremely easy to make a pie chart in programs like Microsoft Word and Pages. We'll just do our best here with doing it by hand. I would go with let's take a look at the relative frequencies. I'll probably do venti first because you can see 0.25 is the relative frequency, and I know that 0.25 is exactly a quarter of a circle. So let's go with that one first because we can probably visualize easily what a quarter looks like. So I'll label this venti, 25%. Okay, and then the next, the highest one was grande with 0.35 or 35%. 35% is a little bit more than a third, so I'll just make this quite big. So we have Grande, 35%. Okay, what are we missing? We're missing Tall, and we're missing Trenta. So Tall was 30%, Trenta was 10%. So let's go ahead and kind of figure out maybe something like this. So I'll say Tall, 30%, and this will be Trenta, 10%. Not perfect, but you know, it's okay. Just kind of trying to make sure that the sectors of the circle are proportional. All right, next example. A survey of 100 randomly selected autos in the luxury car segment and 100 randomly selected autos in the sports car segment that were recently purchased yielded the following colors. So part A says construct a relative frequency distribution for each car type. In this particular example, we're kind of lucky because the sample sizes were 100. So anytime you divide by 100, that just moves the decimal place 2 places. For example, 25 divided by 100 is 0.25. So these relative frequencies will be fairly easy to compute. I'm just going to go ahead and fill them in, move the decimal 2 places to the left. So for white, 0.25, black, 0.22. Here we're looking at the luxury car color. So blue, 2 places, so 0.07. Red, 0.07. Gold, 0.06. Green, 0.03. And brown, 0.02. And then we're also going to find the relative frequencies for the sports cars. So same thing, move the decimal 2 places to the left, so 10 will be 0.1. I'm doing that because we happen to be dividing by 100 on this particular example. 0.18, 0.15, 0.13. So usually you'll have to divide every single frequency by the sample size. The sample size won't typically be a nice number like 100. Okay, so now with these relative frequencies, we're going to draw a side-by-side bar graph. So let me shrink this down so we can look at the table while we scale our graph. So as I'm looking at these relative frequencies, it looks like the highest one that I have is 0.25. So when I make my vertical scale, I need to make sure it goes up to 0.25. So let's go ahead and start drawing in our scale, our axes. So I need to decide what to go up by. I think since I'm going up to 0.25, I'll go by 0.05s. So here will be 0.05, then 0.1, 0.15, 0.2, and that gets me to 0.25. You can choose to do this differently. That's okay, but whatever scale you do choose, it does need to be consistent. Otherwise, it could distort your data. Okay, so I'm going to label this relative frequency. Anytime you do a side-by-side bar graph, you're going to want to use relative frequency to make a fair comparison. In this example, the sample sizes were equal, so it didn't really matter. But often the sample sizes will not be equal, in which case the only fair thing to compare would be relative frequency. Okay, so now we're going to label this axis car color. Okay, so we have a lot of colors here, so I'll make sure I fit them all. So I have white, black, and I'm leaving 2 squares for each because I'm going to make my side-by-side bars. Silver, gray, blue, red, gold, green. Oh, it barely fit. Brown. Okay, and when you have side-by-side bars, you typically will make them different colors. If you don't have colors, you can make them different patterns, you know, polka dot stripes, whatever. I'm going to go ahead and go with green for the luxury, red for the sport. So I'll make a little key up here. So green for luxury cars, And I'm going to do red for sports car. So this is my key, so that anyone looking at the graph can know what the different colors represent. And now I'm going to go ahead and make the bars for each one. So for the luxury cars, 0.25 of them were white, so it's quite a lot of them. A quarter of the luxury cars were white. I'm going to go down and fill in all the luxury cars first, then I'll go back and fill in the sports cars. So for luxury cars, black, 0.22, so almost up to the previous one. Okay, luxury car silver, 0.016. Oh, 0.16, my bad. Okay, so we'll go a little bit above the 0.15. Okay, luxury car gray, 0.12. So a little bit above the 0.1. Luxury car blue, 0.07. So it's a little bit higher than the 0.05. Luxury car red should be the same height as the previous one, 0.07. Luxury car gold, a little bit shorter, 0.06. Luxury car green, 0.03. So almost up to the 0.05, not quite. And then brown, 0.02. So very small bar here. Okay, now we're going to go back in and make the red bars for the sports cars, and they're called side by side because they will be touching the luxury car bars that match the same color. Notice I still left some gaps between the bars. So for sports car white, 0.1, so right here. Sports car black, 0.15, so right up to here. Sports car silver, 0.18, so almost up to the 0.2. Sports car gray, 0.15. Sports car blue, 0.13. Sports car red, 0.15. Thought there'd be more of the red, but maybe not popular as it used to be. Okay, 0.15. There we go. Gold, 0.05. Green, 0.02. And then last one, brown, 0.07. Okay, so you can see that looking at a side-by-side bar graph gives you more of a visual of the comparisons. Like, wow, luxury cars, a lot more of them are white than sports cars. There are more red sports cars than red luxury cars. It's something to look at other than just kind of looking at a list of numbers, which may be a little bit more difficult to compare. Now we're looking at displaying quantitative data. 25 randomly selected middle school students were asked how many siblings they have. Organize their responses in a frequency and relative frequency distribution. So notice that we have the raw data here. The lowest number is 0, the highest number is 4. So let's go ahead and fill out this column with a table. And now for the frequencies, we just want the counts. So how many said 0? 1, 2, 3, 4, 5. How many said 1? 1, 2, 3, 4, 5, 6, 7, 8, 9 of them had one sibling. 2 siblings, 1, 2, 3, 4, 5, 6, 7. 3 siblings, 1, 2, 3. And it looks like one person had 4 siblings. Okay, so the relative frequency we need to get by dividing by the total. There were 25 that were surveyed, so we'll divide each of these values by 25. So for 0 siblings, 5 divided by 25 is 0.2. For one sibling, 9 divided by 25 is 0.36. For two siblings, it's 7 divided by 25, so 0.28. For three siblings, it's 3 divided by 25, so 0.12. And for four siblings, 1 divided by 25, 0.04. Okay. Moving on here, we've been given a table, a frequency distribution with classes, and we want to identify the following. So part A says LCLs, lower class limits. So that refers to these numbers here that are the lowest value in each of the classes. So we have 0.00, 1.00, 2.00, and 3.00. B, the UCLs are the upper class limits, so those are the numbers over here. The highest number in each class, so we have 0.99, 1.99, 2.99, and 3.99. And then lastly, the class width. The class width is the difference of consecutive upper or lower class limits. So I'm going to take a look at these last two lower class limits. I'll just subtract them. So the class width is 1. So you'll notice that the lower class limits go up by 1 each time, and the upper class limits also go up by 1 each time, and that is why it's called the class width. Now we want to construct a frequency distribution with class width 3 for the following set of data. So I know the class width is 3. The question is, where should I start? Well, if we examine the data, we can see that the lowest number is 60.25. That's kind of an awkward number to start with, so I would probably choose to start with 60, which is a little bit lower, and it's a nice round number. Now the class width is 3, so the class width is the difference of consecutive lower class limits. So the next lower class limit would be 63, and we can just keep adding 3 to go all the way up. So now the question is, what is the upper class limit for the first class? Well, it needs to be less than 63. It also needs to have 2 decimal places because all of our data has 2 decimal places. So the number that is right below 63 with 2 decimal places would be 62.99. And now I can use the class width to fill in the rest. So I'm just going to add 3 each time. Add 3, add 3, add 3, and add 3. Okay, now we can go ahead and find the frequencies by filling in where these go. It might be a little bit easier to just do a tally, go data value by data value, than to try to count. So 60.25 is in the first class, 62.87 goes also in the first one, 64.08 goes in the second one, 68.56 goes in the third one, 62.31 goes in the first one, 65.46 goes in the second one. So we'll keep on going down and just deciding where each of these goes, which class they fit into. Okay, so I'm going to keep going until I've exhausted the entire set of data. Okay, so I probably don't want to leave these as tallies. I'm going to go ahead and write the numbers. So we have 4, 6, 3, 2, 1. So for this next example, we're being asked to construct a histogram to display the height data from the previous page and classify the shape of the distribution. So the frequency distribution has been restated. So I'm going to go ahead and draw in the axes. We'll do some labels here. So I have height in inches. And I have frequency. And the frequency should go up to at least 6 because that's the highest frequency. So 1, 2, 3, 4, 5, 6. Now on the horizontal axis, I'm just going to keep this neat and tidy by only including where each bar starts. So I'm going to go 60, 63, 66, 69, 72, and then close it off with 75. You don't need to put all of the class limits. You don't have to put lower and upper. That's just going to take up a lot of space and be a little bit of clutter. Now this is a histogram, so the bars do touch because their spatial relationship has a meaning, right? Because of the numerical nature of the horizontal axis. So we'll now have the heights of the bars display the frequencies. So for the first class, it's 4. Okay, go ahead and just change the color so it's easier to look at. The second class, the height will be 6 for the frequency. I'm keeping the bars of equal width, of course. And then for the third class, the height of the bar will be 3. Okay, the next bar, the height should be 2. And for the very last bar, the height will be 1. A random sample of Disneyland guests was asked their ages. The data appears in the table. Construct a stem and leaf plot to display the data and classify the shape. So a stem and leaf plot will divide the data into 2 pieces, a stem and a leaf. So because many of these are 2 digits, I would say the stem will be the tens place and the leaf will be the ones place. So the lowest age is 3, the highest it looks like is in the 40s. So my stems will have to go from 0 to 4. So those are my stems, and now I'm going to put in the leaves. They should be in ascending order, and they should be consistent size. So for the tens place of 0, I'm looking at, there's 2 single-digit ages, 3 and 5. So those will be my first 2 leaves. Then for the ages in the tens, I have a 10-year-old, a 13-year-old, and a 15-year-old. So 0, 3, 5 will go on my second stem. And then people in their 20s, we have two 21-year-olds. We need to account for both of those. Trying to keep the numbers a consistent size. Then we have 26, 28, and 29. So 6, 8, 9. Then people in their 30s, we have 32, 38, and 39. So 2, 8, 9. And then there are 2 40-year-olds, so that will be the last 2. So we have a 44-year-old and a 45-year-old. I'm classify the shape. If you look at it kind of sideways, you can see that it's roughly symmetric. And I just realized we didn't classify the shape of the previous one. So let's go ahead and scroll back and take a look at that graph and classify it as well. So looking at these heights, we can see it tails off to the right more so than the left. So I would call this graph skewed right. And that would be the shape. Usually we'll say skewed left, skewed right, or symmetric bell shape. Let me include that as well. It's not just symmetric, it is also bell shaped. I'm saying that because a uniform distribution is also symmetric. One more example, a random sample of mall goers was asked, how many stores have you gone into? The results are in the table. Make a dot plot and classify the shape. So a dot plot is kind of a quick and easy graph to make for very limited numbers of data values. So it goes from 0 to 4. So 0, 1, 2, 3, 4. Labeling those, and what we're literally doing is stacking dots. So I can go value by value, so 3, put a dot. 2, also have a dot. 4, 2 4s in a row. So this one's pretty easy to make. Just try and keep your dot sizes consistent. Go 2 again. 3, 0, 2 3s in a row. I probably didn't put enough space. That's okay. 4, 3 again, 4 again, 2, and then 2 more 3s, which will go up into the words. That's all right. Classify the shape. We see this 0 is kind of skewing the graph to the left, so I will call the shape of this graph skewed.